A rectangle has sides of 6 and 8. Construct a diagonal of the rectangle, dividing the rectangle into two triangles. Inscribe circle X in one triangle and circle Y in the other triangle. The question is, what is the length of XY, the distance between the two circles' centers?
We are given a rectangle. We know its sides measure 6 and 8 units respectively. Next, we draw one of the diagonals. Using the diagonal, we construct two circles that are tangent at the corresponding points of the rectangle. Our objective is to determine the distance between the centers of these two circles. To solve, we will start by naming the distance as D. We will construct the following right-angled triangle. Observing vertically, we understand that these two distances are actually the radius of the circle. This implies that the vertical side of the triangle will be 6 minus twice the circle's radius, 6 minus 2 times r. Similarly, by looking horizontally, we can determine the horizontal side of the triangle to be 8 minus twice the circle's radius, 8 minus 2 times r. By applying the Pythagorean theorem to the right-angled triangle, we can state that the square of distance d is equal to the square of 6 minus 2 times r, plus the square of 8 minus 2 times r. After expanding the brackets, we get that the square of distance d equals 36 minus 24 times r plus 4 times r squared, plus 64 minus 32 times r plus 4 times r squared. Further simplification leads us to conclude that the square of distance, d, equals 8 times r squared minus 56 times r plus 100. This is the first useful relationship, and it will help us in the future. The next step is to construct the following right-angled triangle. One of the sides of this triangle is the radius of the circle itself. As we mentioned, we know that this distance is also the radius of the circle, which means that the other leg of the triangle will be 6 minus r. We can apply Pythagoras' theorem to this right-angled triangle to find the value of the hypotenuse x. By applying Pythagoras' theorem, it results that the square of x is equal to the square of 6 minus r plus the square of r. Now we can draw the next radius to construct this right-angled triangle. We can apply Pythagoras' theorem to this right-angled triangle to find the value of the leg y. According to Pythagoras' theorem, the square of x equals the square of r plus the square of y. We want to find y, so we will rearrange the terms such that the square of y equals the square of x minus the square of r. We have previously calculated the value of the square of x. By replacing the square of x in the relationship, we obtain the square of y equals the square of 6 minus r plus the square of r minus the square of r. By reducing the square of r with the square of r, we get the square of y equals the square of 6 minus r, which means that the value of I is 6 minus r. We know that this red piece measures 6 minus r. Now we can focus on the next right-angled triangle to find out the length of the hypotenuse. Since the sides are 6 and 8 respectively, the hypotenuse will be 10. So we know that the length of this diagonal is 10, which means that half of the diagonal will be 5. But we have just calculated the red piece to be 6 minus r, which means that the other piece will be 5 minus 6 minus r. We can apply Pythagoras' theorem to this right-angled triangle. We know that its hypotenuse is half the total distance we want to calculate. Applying Pythagoras' theorem results in the square of d divided by 2 equals the square of r plus the square of 5 minus 6 minus r. After making several simplifications, we can obtain that the square of d equals 8 times the square of r minus 8 times r plus 4. We have two different relationships for the square of d. We can equate the two relationships to obtain an equation where r is the unknown. Solving the equation, we find the value of r, which is 2. We can replace the value of r in one of the relationships for the square of d. By substituting, we get that the square of d equals 32 minus 112 plus 100. From this, it results that the square of d is 20, which means that the value of d is 2 times the square root of 5.
Here's one way to solve the problem. Construct a right triangle where one leg is the vertical distance between x and y, and the other leg is the horizontal distance between x and y. Then xy is the hypotenuse of this right triangle. In circle X, construct radii to the tangency points with the rectangle. Let r be the length of the radius. Do the same thing for circle Y. Now, construct the following two line segments from the other corner of the right triangle. Each of these line segments has length equal to r. Then, the shorter leg of the right triangle has length equal to 6 minus 2r, and the longer leg has a length equal to 8 minus 2r. Thus, the length of the hypotenuse is equal to the square root of the sum of the squares of the lengths of the legs. All that remains is to solve for r, the radius of the inscribed circle. Let's solve for that now. Let's focus on 1/2 of the rectangle. This right triangle has legs equal to 6 and 8, which means its hypotenuse is equal to 10. The area of half of the rectangle is equal to 6 times 8 divided by 2, which is equal to 24. But there's another way that we can solve for the area of half the rectangle. Construct the following radius of circle X to the tangency point with the diagonal of the rectangle. We'll now construct 3 triangles. This triangle has a base equal to 6 and a height equal to r, so its area is equal to 6r over 2. This triangle has a base equal to 8 and a height equal to r, so its area is equal to 8r over 2. This triangle has a base equal to 10 and a height equal to r, which means its area is 10r over 2. The sum of these 3 areas is equal to r times the semi-perimeter of the triangle, which is also equal to 12 times r. This is also equal to half the area of the rectangle. Thus, we have 12r is equal to 24. We divide both sides of the equation by 12 to get that r is equal to 2. We now substitute in for our formula for xy. This means xy is equal to the square root of 2 squared plus 4 squared, and that's equal to the square root of 20, which is approximately equal to 4.472. And that's the answer.